and its physical nature as well as its availability and covalent compound. The carbon is found in the atmosphere inside the Earth's crust and also in all the living organisms. Carbon is present in fuels like wood, coal, charcoal, coke, petroleum, natural gas, diamond, marsh gas, etc. So the carbon is found in the free state as diamond, which you can show in the figure like this, as well as graphite, which we use in our pencils, and fullerenes. Fullerene contain football structures. The carbon is present in compounds like carbonates and hydrogen carbonates. So the how bonding in carbon takes place. So the covalent bond is present. The atomic number of carbon is 6 and its electronic arrangement is 2 and 4. So still it needs 4 more electrons to gain noble gas configuration. So hence its valency is 4. So that is it is tetravalent. Tetravalent is 4 electrons. Formation of covalent bonds. Actually, the covalent bond is a chemical bond formed by the sharing of electrons between atoms. The sharing of one pair of electrons results in the formation of a single covalent bond. Sharing of two pairs of electrons results in the formation of double covalent bond. And sharing of three pairs of electrons result in the formation of triple covalent bond. Let us see how they are formed. Formation of single covalent bond in hydrogen molecule. The atomic number of hydrogen is 1 and its electrons, the outermost electrons, only one electron. So if you take one hydrogen, it contains one electron, and if you take one more hydrogen, it contains one electron. So these two electrons are shared. So the covalent bond is formed when two electrons share with each other, result in the formation of a single covalent bond. Formation of double covalent bond in oxygen molecule. The oxygen molecule will have two single bonds. That means its electronic configuration is 2 and that means it needs 2 electrons more to attain stability. So two oxygen atoms share two pairs of electrons, result in the formation of a double covalent bond in oxygen molecule. In the same way, triple covalent bond in nitrogen atom. It has 5 valence electrons. If you take atomic number of nitrogen is 7, it needs 3 electrons more to attain stability. So two nitrogen atoms share 3 pairs of electrons, resulting in the formation of triple covalent bond in nitrogen molecule. So here is how the covalent bond is formed among the atoms in different molecules. See here, the two hydrogen atoms will combine together to form a single covalent bond. Two fluorine atoms together to combine to form a fluorine molecule. Two oxygen atoms and carbon atom combine together to form carbon dioxide molecule. Whereas for fluorine atom as well as carbon atom together to form CF4, that means carbon triple fluoride, carbon tetrafluoride. Let us see the electron dot structures of methane molecule as well as ethane molecule. Methane molecule means it contains a single carbon, ethane molecule contains two carbons. Formation of a very large number of carbon compounds. So why only carbon exhibit this type of properties? Carbon forms a very large number of compounds. The number of carbon compounds is more than 3 millions. It is more than the number of compounds formed by all the other elements. This is because carbon atom can form bonds with other carbon atoms to form chain-like structures. See, there are many chain-like structures like long chains, branched chains, and closed ring structures. This property is called as catenation. Since the valency of carbon is 4, it can form bonds with other carbon atoms or with other atoms of other elements like hydrogen, nitrogen, any other element. So this is called as a catenation capacity. Catenation capacity is the property which is useful for carbon to form long chain-like structures. This is a peculiar property and special property of the carbon atom. Next, hydrocarbons as well as the saturated and unsaturated hydrocarbons. Let us see what. Hydrocarbons are compounds containing carbon and hydrogen atoms. Hydrocarbons, the name itself says that it contains carbons as well as hydrogen. Saturated hydrocarbons are hydrocarbons having single covalent bonds between the carbon atoms. Saturated means single bond, whereas unsaturated means it will have double bond as well as triple bond. For example, if you take alkanes have all single bonds between the carbon atoms and their names end with "ane". Alkanes. Anes means it contains only single covalent bond. They are saturated hydrocarbons. Best examples are methane as well as ethane. Whereas if you come to unsaturated hydrocarbons, they contain either double bond or else a triple bond. That is why they are called as unsaturated hydrocarbon. Best examples are alkenes and alkynes. The name enes contains ene constitutes two bonds, that means double bond, whereas alkynes contains a triple bond between the atoms.